Hello grade 12s. Today I'm looking at the 2018 trials paper. There were two options that they gave for the trials paper, one with the branch pipe coming out horizontally and one with the branch pipe coming out at an angle but still being cut off in a vertical line. These are the main two types of interpenetration curves that we can get when they have the pipe being projected out parallel to the base of the shape, and the other one is if it is tilted or inclined to the base. Now, when it is like this, it is important that we have the auxiliary view, and we need to be able to transfer measurements into the auxiliary view and correspond those with an auxiliary view in the front view in order to calculate where we're going to find the points for the curve of interpenetration. So please understand the key differences here. When it is parallel, we have to have the auxiliary view here so that we're able to take the measurements up. If the branch pipe was at an angle going into the main pipe, what we can do is take where the points are in your branch pipe in the top view, and we can project them up to that branch pipe and project them down parallel to the incline of the branch pipe. That's not the case now, so we need to use the auxiliary views. With any drawing that's got a circle, we need to put in our pizza slices. So divide this up into the 12 equal sides, and then I'm going to label them. The nice thing about this auxiliary view is it's parallel to the base, so we just need to rotate the numbering by 90 degrees in the top view. There I've put in my pizza slices, numbering clockwise 1 to 12. It won't really matter if you labeled it anti-clockwise. Now remember, we need, when we're looking at it from the top view, it rotates from the front view by 90 degrees. So that's how this numbering has now rotated 90 degrees. So 0 starts on this side. If you think about it as well, when we look at it from the top view, this is the highest point on my circle, which would be at this point. So we've got a completed front view. What I'm going to do now is project my points up and find where those points are in my front view so I can get the curve of interpenetration. What I'm going to do is start by doing the points up to my turning point here of the shape. So speeding things up now, hopefully we've got a better idea of what we're doing. So what I've done is I've projected these first points, a lot of points, across to where they hit my main pipe, and I'm going to project them up. I've projected my points up, and I've labeled those lines that I've projected up. Now we're going to take the corresponding number and project it to that respective point. So let's start at the top. The top is 0, and here is my 0 and 6 line. So I need to project 0, which is the highest point, to hit at 0. My next point is point 1. Project that to intersect at line 1. Next point is point 2. Project that to cut point 2. Point 3, the widest point, is touching the last line or the edge of my triangle. Point 4, 5, and point 6 is my lowest point. And those are the points that I'm going to see, and I'm now going to go over those in a dark line. There's the completed outline. I now need to find the turning point, and the remaining points, all of these points will be in hidden detail. So I just like doing it that way so that I can see what my outline of the shape is, and now I know that the remaining points that I'm going to find will be in hidden detail. I've projected these back lines across to where it touches the triangular main pipe, and I'm now going to project those points up. There are the points being projected from my triangular main pipe. Now let's match them up with the horizontal lines taken from the front view. So I'm going to start with point 9. There is point 9. Point 10. Point 11. It's going to come to the turning point I'll come back to. I'm going down the other side. There's point 8. And 7. Let's get the turning point now. So the turning point cuts our auxiliary view here. So I need to come and find a center. So I'm going to take point 9, get the measurement to my turning point, which should be the same on both sides. I then go to point 9 in my front view, the auxiliary view in my front view, and mark off where that turning point will be at the top and the bottom of the shape. And now we need to project that turning point to see where it hits on the edge here. Very close. So a very tiny little space there, but that's the turning point. So we now need to join up the following points. Point 6 goes up to the turning point, then back to point 7, 8, 9, 10, 11. 11 goes to the turning point and then back to point 0 and 12. Very tiny hidden detail line is supposed to go up from the edge here to where that would be. Fortunately, we can't really get any space there. I'm now going to go over that in an outline. There I have my completed curve of interpenetration in the front view. The next step that we're going to do is develop the prism. I only show the two sides that are being cut. Now the advantage of this is we've got space to project our lines across to get the development over here, and we can then transfer the height measurements straight across to the development. Our width dimensions we need to get from the true shape here that we get in the top view. I've projected my height dimension across and I've marked off the lengths. So what I've done is I've taken the distance A to B and just labeled those corners A, B and C, and let's mark off the same in our development. Let's get the easy parts first. So at A we've got point 3, so I'm going to project height 3 to cut at A. So that gives me point 3. At B, it is my turning point, so I need to take my highest turning point, mark that off, and my lowest turning point and mark them off. So those are the only 3 points that we've got on our development. of the corners of the triangle. Let's calculate the rest now. Try and use a logical approach to the drawing now. So I've got point A, which is on this edge. Let's take the next corners up, so points 2 and 4. So remember, we need to get our sort of width dimensions from this triangle, because it's the true shape. What I'm going to do is I'm going to take the distance from B to A, and where 2 and 4 is, I get that distance with my compass. So I go and put my compass at B, mark that off towards A. That point now gives me where point 2 and 4 is. Next point will be point 1 and 5. Sorry. Take the distance 1 and 5 from B, mark it off. My next point I'm going to mark from A. So I'm taking the distance to find where 0, 6 and 12 is. There's the distance. So I go to A, mark off that distance, which is giving me 0, 6 and 12. I'm now going to draw in the vertical lines and transfer my heights from the front view. So here I'm projecting my heights. Here's height 4 going to the vertical line 4. Here is my 2 going to point 2. Next numbers 1 and 5. So there's point 1. Here is point 5. Projecting the height across to the vertical line. Next is my highest point. You know that is our highest point. This is our lowest point. So there's 6, 0 and 12. Okay, we're going to follow the same process on the other side of our shape. I'm marking off my measurements on this side now. So here's B to point 9. So I put my compass at B and mark off my distance to 9. Take my next distance, so this is 8 and 10. Mark it off once again from B, giving me 8 and 10. And my last one, I'm going to just swap this around. I like measuring bigger distances with my compass. That distance is 7 and 10, but I've measured from C. So I go and put my compass at C and mark off points 7 and 10. I'm going to now draw in the vertical lines. I've marked off the height measurements now, the width measurements, and I now need to get the height measurements from my front view. There's point 11. Next is point 10. My further is point 9. 8. And 7. They're all my points, and I need to join them up and go over the outline of my shape. This line here between B and the top of the shape will be in dark because that would be the fold of the triangle. And there you have the completed development